Hi everyone. In the last video we have seen how to find zeros of the polynomial theoretically. Today in this video let us see what is the geometrical meaning of the zeros of a polynomial. Right? First of all, let us see again what are zeros of a polynomial. A real number k is called zero of the polynomial px if p of k is equal to 0. Right? For example, the polynomial px is equal to x square minus 3x plus 2. By putting x is equal to minus 1 in this polynomial, we get p of minus 1 is equal to minus 1 square minus 3 into minus 1 plus 2, which gives you 0. Also, if x is equal to 2, p of 2 is equal to 2 square minus 3 into 2 plus 2, which is also 0. So, because p1 and p of minus 1 and p of 2 are zeros, minus 1 and 2 are called zeros of this polynomial, x square minus 3x plus 2. Okay. This is all how we do theoretically. How do we represent graphically? Now let us see the graphical representations of linear and quadratic polynomials and their geometrical meanings of their zeros. How do we find zeros from graph? Okay, let us see a linear polynomial of the form ax plus b. So let us take y is equal to 2x plus 4. Now let us draw a graph of this by taking some suitable points x and y which satisfy this equation y is equal to 2x plus 4. Okay, so if x is equal to minus 1, y is equal to 2. If x is equal to 1, y is equal to 6. If x is equal to 2, y is equal to 8. Now let us draw a graph satisfying these points. We observe that this is a straight line intersecting the x-axis at minus 2, 0. So the 0 of the polynomial 2x plus 4 is minus 2. Right? So, which is nothing but the x coordinate of the point where the graph y is equal to 2x plus 4 intersects the x-axis. Okay. Now, in general, for linear polynomial ax plus b, the graph of y is equal to ax plus b will be always a straight line which intersects x-axis at only one exact point, which is minus b by a 0. Right. So, this is obtained by putting y is equal to 0 in y is equal to ax plus b. Suppose if ax plus b is equal to 0, then ax is equal to minus b, where x is equal to minus b by a. Right? So, a linear polynomial ax plus b has only exactly one 0, which is minus b by a. Okay, now let us see the geometrical meaning of a zero of a quadratic polynomial. Consider the polynomial y is equal to x square minus 3x minus 4. Here, this is a quadratic polynomial as the highest degree is 2. The variable power is 2 highest power. So, the graph of this polynomial, if you draw, looks like this when suitable points are taken for x and y, satisfying this polynomial. Okay, here we observe that in this graph, the curve intersects the x-axis at 2 points, minus 1, 0 and 4, 0. So, the zeros of this polynomial are minus 1 and 4. Okay, so which are nothing but the x coordinates of the points where the graph intersects the x-axis. Now, the shape of the graph of this quadratic equation y is equal to x square plus bx plus c, the general form y is equal to x square plus bx plus c, can be of any of these three cases that can happen. Let us see the case 1. Here, observe the two graphs carefully. Here, the graphs of a quadratic equation may be of U-shape or inverted U-shape. It will be of U-shape if ax square plus bx plus c a is greater than 0, or if it is a is less than 0 in ax square plus bx plus c, it will be of inverted U-shape. Remember this. Okay. Here, if you observe the graphs, both graphs of here cuts the x-axis exactly in 2 points. Okay. Here the graph cuts the x-axis exactly in 2 points. Let it be like a and a dash. Okay, so the zeros of this polynomial are a and a dash. So that means there is two roots for this, two roots or two solutions for this quadratic equation. Now let us see case 2. Here the graph of the quadratic equation cuts the x-axis at exactly 1 point. You observe here. So that means there is only one 0 for this quadratic polynomial, that is a dash. So that means there is only one root or one solution for this quadratic equation. Okay, and the last case, case 3. Here observe the graph of these two carefully. Here the graph of the quadratic equation completely either lies above the x-axis or below the x-axis. So it does not cut the x-axis at any point. So there is no 0 for this polynomial in this case. Okay, that means there are no solutions for this quadratic equation. Okay, now let us see the zeros of the cubic polynomial.